insulin is supposed to cause blood vessels to expand, especially the blood vessels deep inside muscles. The official name for this process is capillary recruitment. And capillary recruitment is rather helpful since insulin's primary job is to put away the groceries after a meal. Big, wide blood vessels make popping the sugars and things that have just arrived into hungry cells a whole lot easier. But in someone who is insulin resistant, this vasodilation process doesn't happen, and there's a delay in putting the groceries away. Sugar levels rise, resulting in glucose intolerance. And since high sugar levels are especially bothersome, this causes trouble with a capital T. But big, wide blood vessels can be problematic too. There's only so much blood whizzing around, and if you divert the blood into every nook and cranny, the pressure in the system drops. The same thing happens in bathrooms. If you're running the hot water out of one tap, all that comes out of the other tap is a dribble because, well, the pressure dropped. Now, the easy fix in the bathroom for this situation is to turn off the other tap. But in the body, a sudden drop in pressure could see you toppling over because there's a problem with oxygen delivery. So Mother Nature makes a plan. Join us for this episode of Better Body Chemistry TV as we explore how this plan contributes to insulin resistance. Better Body Chemistry TV is brought to you by Dr. Sandy, a scientist turned gremlin buster, helping you battle sugar gremlins, heifer lumps, and other health horribles through better body chemistry. Remember, small things can make a big difference to your health. So, what is the story? Well, it turns out Mother Nature keeps tabs on the quantity and quality of the blood via tiny little bodies located in the main blood vessels running into your head. Bodies, it's kind of a grand term for them. On the outside, they look like little bumps, but these bumps are packed full of nerve tissue. And they keep tabs on oxygen and carbon dioxide levels, as well as the pH of the blood and temperature. Any anomaly in the numbers sparks frantic activity. They fire off signals via the carotid sinus nerve, and things happen. The things that happen include prompting you to breathe better and squeezing the blood vessels throughout the body so that they are a whole lot smaller. Constricting the blood vessels everywhere bumps up blood pressure, returning things back to normal. Well, sort of. In medical speak, this is referred to as vasoconstriction and sympathoexcitation. Now, exactly how these little bodies do this tremendously important job is still a little fuzzy. What we do know, thanks to a team of Portuguese researchers, is insulin triggers the carotid bodies. And when insulin climbs, carotid bodies make things happen. Always. And the happenings last for a few hours. This is great when insulin is putting away the groceries in response to dinner. But it becomes problematic when insulin is high all the time. And it's high all the time when you're insulin resistant. Remember, insulin resistance is selective. Not all cells don't respond to insulin appropriately. In insulin resistance, it is the power-hungry cells, the muscle, liver, and fat cells that don't respond. Carotid bodies do respond. They're not insulin resistant. Hyperinsulinemia keeps carotid bodies pinging morning, noon, and night. The body is permanently sympatho-excited. Translated, blood vessels are smaller. Less blood is flowing and blood pressure is elevated. Ouch. Which decreases insulin delivery, leading to glucose intolerance and more insulin. The Portuguese team demonstrated an overactive carotid body is part of the problem in insulin resistance by observing what happened when carotid bodies couldn't do their job. When the carotid body activity was terminated by cutting the carotid sinus nerve, the problem of insulin resistance disappeared. In this research, the team performed surgery on 2 groups of rats. One group got the snip. The other group were just opened up, but the carotid sinus nerve was not actually cut. These were the controls. 5 days later, the rats were feasting. Quite literally, they were put on a diet designed to put on weight. Rats with carotid bodies got fat and developed the usual metabolic troubles associated with obesity. Rats without carotid bodies were healthy. They never put on weight, their blood pressure remained stable, and they remained insulin sensitive. Were they in perfect health? Not quite. Without the carotid body, the animals are vulnerable to suffocating. Well, you win some, you lose some. It's a vicious cycle. This research confirms too much insulin is a bad thing. One of the reasons too much insulin creates too much sympathetic activity, leaving you living life in a state of stress. And stress kills. So, to create better body chemistry, you need to rein in insulin. For tips and strategies that will help you do this, download the Willpower Report. It's free, and it will introduce you to the Candy Floss system, a 10-step program designed to improve insulin sensitivity so you create better body chemistry. Interested in discovering more ways to create better body chemistry? Visit our website at www.betterbodychemistry.com. Browse our library or enroll in one of our courses or programs. The advice is simple to follow and based on real science, not hype. Know someone living life in a state of stress thanks to insulin resistance? Share this video with them so they understand stress management begins with less insulin. And if you enjoyed this video, be sure to subscribe to our channel so you catch future episodes of Better Body Chemistry TV. Thank you so much for watching, and I'll see you next time. Remember, small things can make a big difference to your health.